This is a discussion of the legal aspects of identifying and describing features and objects on surveys. So surveyors have always needed to record measurements and accurate descriptions of what they measure to. Until the widespread use of data collectors came along, surveyors' best friend was the field book. That's where we recorded everything with pencil on paper. It was easy to sketch on, write on, go back and add information to, compared to a modern raw data file collected with a tablet or a data collector. It had a lot of flexibility and was really nice, but this practice has gone away now because of all of the electronic devices that we use as surveyors. And the level of detail that's reported and reflected in the field data has suffered because it's not as easy to do that. Now, I will sidebar note and say that I encourage all field people, even if you're using a tablet, data collector, whatever, yes, take pictures, but carry a field book. You'll find it easy to sketch in, it's hard to lose, photocopy or scan that, let it be part of the permanent job record. One of the things that we do in my firm is we use that to record the time and the point number of GPS observations so that we know that we have at least a 90-minute window of time lapsing between redundant observations. So there are a lot of ways that the field book can and should be still incorporated. But that's not what we're talking about. What we're talking about is collecting and identifying descriptions and data so that our survey does not just become a bunch of symbols plotted in space. So, ironically, in the days when we used field books and measured and recorded our angles in a field book, we had a lot more attention to detail, a lot more detail. But now that the need is even greater than ever for that amount of detail and accuracy, we've gone in the opposite direction. So, while we're not going to deal with manufacturing history of survey monuments, we're not going to train everybody to be professional foresters or civil engineers. We're going to try to cover the basics of what surveyors should know. This is a very high altitude overview. The underlying theme will always try to be the legal aspects of it. You know, we're not going to teach you how to measure a rock or a culvert as far as the hands-on, but the implications of doing it correctly and incorrectly. So let's start with topographic natural features. So we've already studied riparian boundaries, which is a very topographic natural feature. But there are other features that may be incorporated into property boundaries that were very convenient for the old timers. It might not have been exactly what they wanted to sell or where they wanted to sell to, but they might have said, you know, there's an old road that goes down through there. Let's just make it the line that's visible. Everybody knows where it is. So that saved the need for surveying, and it saved the need for establishing new corners and monuments and things. And so they were often used. And you know, sometimes it was just because somebody didn't want anything on the other side of that road, or they only wanted to own to that road or that swamp. Maybe they were trying to buy and sell some property, and one party just really didn't want to own any swampland, and the other party was like, well, I don't care, I'll keep it. So using that all for an example, you know, another common topographic feature are ridge lines, especially in hilly or mountainous property, because people were generally familiar with where the ridges were, and they form a practical boundary. If you're harvesting firewood, grazing livestock, building a house, you really just benefit from what's on the convenient side or the actual side of the ridge where you're building or harvesting timber or whatever, because it's downhill all the way to the road. To go to the other side of the ridge, you have to then carry it, haul it, pull it, drag it up to the top of the hill just to get there. So people often didn't care anything about keeping property that they owned on the other side of a ridge. So for example, here on this USGS map, we see one property line might have been a ridge. Might have just followed on out that ridge in a northeasterly direction. And then the ridge kind of plays out. They would have needed to have identified continuing in the same direction, going north 40 degrees east, etc. Another possible boundary that you might have seen pop up from this would have been possibly the edge of Salt Creek Swamp. So you can kind of see the orange line there. That looks to be about where the edge of the swamp would be. Well, people knew where their swamps were, and so they may have well said, you know, this is going to be the boundary. You're going to own over here. I'm going to own over there. And that's just how it would have been done. They wouldn't have used a USGS quadrangle map. They would have just been familiar enough with their property to describe it. But this is how it would have wound up looking on a plat. So there's a lot of techniques there. You have to really think about what you're locating and why. Where is the edge of the swamp? It's usually very subjective. Where is the middle of a ridge? You can have disagreement over where a ridge is. You have to pay attention to the detail. A ridge is often a kind of a flattened, like a plateau on top of a hill. Well, what if it's not exactly flat? Is the line the top of the highest point, or is it the middle of this flat part along the top of the hill or the mountain? You have to look at the language in the deed. Does it say along the center of the ridge? Well, then it's probably along the center of that flat area along the top, although not all ridges have a flat area on top. So it's very situational. You know, in lack of other qualifying language, it would be the highest point. One explanation I had given to me early on that still makes sense is if you placed a beach ball out there with no wind blowing, when it started rolling from one direction to the other, that's where the ridge is. Of course, it's also a topographic feature where you can determine, that's the watershed divide. That's, from that line over in one direction, the water flows over to one side of the hill, and from the other side of the ridge, it flows in the other direction. Then there's artificial physical features. This is a photograph of an old wood fence that encroached a few feet over a property line. But there are a lot of artificial or man-made features which we have to be able to identify, describe, accurately locate. This might be old timber lines. Might not have been created as a property line, may have later become a property line, or may have been an approximate line where they went out to market to define by agreement where their line was. Fences, old wire fences, old wood fences. All of these things could be part of an old property line, or you could make it a new property line. Most people don't put their fences right on an existing property line because then half of that fence becomes it becomes common property, half owned with the adjacent owner. So in this example, if this was the property line right down through the fence, then both parties have joint custody of that fence. So if someone was dividing a larger tract and they had a cross fence for livestock, or a fence to keep people keep their livestock from wandering down into the swamp, they might have sold to the fence simply because that was a known object that they could easily identify and point to. And in those situations, the fence becomes common property because both sides share in it equally. Old road beds are often property lines because, for the same reason that I didn't need a little quarter of an acre across the road. I've got 15 acres over on this side. They might have sold off the other side, or that may have been just divided out to use the old road. Depending on the age and the history of the old road, you might find an old road bed that's 20 or 30 feet wide, as in it was a 2-lane road with a lot of traffic on it at one time. It was probably abandoned when a newer location was established that had better grades, sight distance, was less curvy, etc. And the old road was just left abandoned. Now the road bed itself is the property line. A lot of people make the mistake of seeing a Jeep trail, 4-wheeler trail, or a path that people are maintaining that's probably 1 lane wide now because of the lack of traffic. And they'll use the middle of that lane as the property line, when that's actually not the property line. It would be the center of the road bed, and that Jeep trail or that driveway may not be in the middle of the road bed. So you have to locate both, and you need to pay attention to that because the the boundary would be where the object was at the time of the conveyance. So if it was a 2-lane dirt road in 1940, and that's what they divided to, then everybody went to war, they came back, the state built a new road over here 150 feet to the west. Now this old road beds the property line, it's got trees here and there in it. That new driveway location is not where the property line was in 1940. It has nothing to do with where the property line was in 1940. You have to think about following in the original footsteps, identify that road bed where it would have been in 1940. That's where it is. Sometimes physical features like this get altered by mass grading, highway construction, borrowed pits, landfills, and things, and you have to rely on some historical evidence, sometimes tie in some old USGS quadrangle maps to try to understand where these physical features were if they're not where they are now. We'll also have to be very careful about describing monuments. So Black's Law Dictionary, which is where you'll find the correct legal definition of just about everything in the world, calls monuments, in the sense of real property, any visible marks or indications left on natural or other objects, any physical object on ground which helps to establish location of boundary line. So proper identification of monuments is crucial. This is one of the most important things that surveyors can do. Retracing surveyors should have a description of the monuments that they are looking for. Recording and later recording on plats, the monuments found or set will become the legacy of the survey. I found this, I set that. That's the legacy that we go back to. Not legacy as in making ourselves famous. Legacy is in, this is what we leave behind for others to look on, literally. So misidentifying a monument creates problems that can haunt a chain of title for years. Take, for example, surveyor, field guy got in a hurry, looked down, didn't want to take the time, called it a 1/2-inch rebar, and recorded the shot and went on. PLS is reviewing the data, looking at it, wow, there's a 3/8 rebar called for. We didn't find it. We found a 1/2-inch rebar. Some numbskulls come along and set a 1/2-inch rebar there. Go back out there and look for a 3/8 rebar. If you're lucky, the field guy or gal will say, this is really 3/8, my bad, that's the pin. Whew. What happens all too often, especially seemingly in Metro Atlanta, is some guy in the office says, well, that's a 1/2 inch, that's nothing, we can't hold it, it's not the 3/8 that was called for, it's a 1/2 foot from where it was supposed to be. Go back out there and drive one in the right place, and then you start pin farming. Driving pins in a close proximity of each other, a horrible practice that should be a felony. It's horrible. It makes surveyors look like absolute morons. It confuses the general public, creates all kinds of title issues that people don't understand. So get it right the first time, or fix it when you do. Don't go out and set a new 1/2-inch capped rebar 4800ths from the correct monument. Make sure you don't do that. If you find the 3/8, call it a 3/8 so that everybody knows what it is. Natural monuments do exist. They're usually stones or rocks. You might also be trees, which we'll get to in a minute. Let's leave with this. As much practical detail as possible should be recorded in the field, and a practical description stated on the plat. So it's often to go into a lot more detail in the field book or in the description line of your raw data record than what you really need to put on the plat, but it's great to provide all that information. So over here on the left we have like a 6-inch by 3-inch rock. It's pretty clear that that was not set there. Somebody put it there. It's standing straight up. It may be angled with the property line the way it comes in and bends. Don't be confused by this. This is an orange stake, a wood stake that someone set behind it to indicate it. And notice we have a little bit of a bearing tree, a little bit of a BT, a little bit of a witness blaze on this pine over here pointing towards that to indicate that it's the corner monument. Here, those with field experience I've seen many times, this is your trusty 1/2-inch rebar in a rock pile. And in rural areas, these will be left sticking out of the ground far enough to be easily seen and found, hopefully, although leaves can cover them up. In urban and suburban areas, these are probably going to be driven flush with the ground, where lawnmowers don't get them, where people don't stump their toes on them, where people won't drive over them with a car. A 1/2 inch, 3/8, 5/8, whatever rebar sticking out of the ground 2 or 3 inches will cut the prettiest circular hole directly into a tire and cause it to almost explode instantly. So don't drive over any rebars, and that's why they're flush in the more well-traveled and developed areas. These are things that we need to know as surveyors. Don't be always looking for a pin sticking out of the ground a 1/2 foot. If you find one sticking out of the ground a 1/2 foot in an urban or suburban area, that's probably a clue that you need to look around the base of it, because the actual corner is probably, flush with the ground or below the ground surface. So let's talk about trees as boundary evidence. So we can have markings placed on trees, spray paint, flagging. That's somewhat temporary. It will go away with time. What's not temporary are scars, blazes, hacks, chops. These cut into the pulp of the wood, they scar. The bark always looks different after that. This is something that you'll find in retracing older boundaries done by real surveyors that blazed the lines and marked the trees. They may also be corner monuments. It's not unusual to have a call so many degrees, so many feet to a red oak, to a elm, to a hickory, to a blazed pine tree. So surveyors don't have to be professional foresters, but how do we address this? Well, if you're doing your reconnaissance and your early research and you see a call for a 16-inch elm tree and the description is dated 1984, then you might want to go see how fast an elm tree grows. If you can do some research online, see how big it might be 40 years later, for example. You need to do some online research and find out what an elm tree looks like, what the leaves look like. That's what you're looking for. If you can't identify it, don't misidentify it. If it's a maple and you just got confused or you just assumed that it's the elm, you could be creating a real serious mistake by calling a maple tree an elm tree. If you're in doubt, just call it a tree, because then you're not misstating anything. You might be understating, but you're not misstating. It's far better to say tree than to say maple tree when an elm tree is called for, or vice versa, or a pine instead of a spruce, or a hemlock instead of a cedar, a birch instead of a beech. These are things that just make sure that you know what you're saying. If you don't know, don't say it. It's pretty easy. If you look here at this chart, you've got deciduous trees or hardwoods. Willows, birch, maples, oaks. That also includes hickories, ashes, poplars, sourwoods, dogwoods. If they shed their leaves, they're going to be hardwoods. The wood itself is going to be very hard. Softwoods, evergreen trees, they don't shed their leaves annually. They keep a leaf or a needle. So you've got cypress trees, pine trees, juniper trees, cedar trees. This is all across the country. These are coniferous trees or hardwood trees, softwood trees or evergreen trees. So, if all you can do is say coniferous tree or softwood tree, or just tree, that's better than calling it something that it's not. One thing that we want to talk about too, though, is typical in measuring trees, because the diameter sets it apart. If the deed calls for a maple tree and the description was wrote in 1905, and you find a 6-inch diameter maple tree, that tree is not big enough to be 120 years old, much less to have been big enough to have been identified by a surveyor or a property owner as a good property corner 120 years prior. That maple tree may not be around anymore. They get so big, and then the wind, root rot, fungus, most trees don't make it that long. But you need to know, well, here's a maple tree, this must be the corner. No, not if it was called for on a deed in 1905. But the way we identify them, the way we label them, the way we report them on our professional work products is a diameter typically. And it's usually at what's called breast height, or about 42 inches, about 3.5 feet off the ground. That way we're not measuring down at the root or at the stump or up at head high. because the diameter gets narrower generally the further up you go. So that's a consistent place to measure trees, and that's important to know. So just to give you a glimpse, some surveyors, especially in generations past, were also or first foresters. Foresters and surveyors historically have similar workplaces and tasks. They're looking at land, they're looking at what's on the land. Now that the tracts are not always so big, forestry is more in decline, surveying is not. But dendrology is the study of tree identification. So I pulled this chart from 8billiontrees.com, giving them the credit. And this is a chart that shows what looks to be 13 different types of oaks. This will give you an example. If a deed call or a survey calls for an oak, you need to either say yes, it's an oak, be able to identify it and know what makes it an oak and not a maple or not a pine or not a spruce. Sometimes you have to get more detailed. Now, in the practice of professional surveying, you might have to do tree surveys. So if you're asked to do a tree survey, this would be for a tree ordinance or a landscaping ordinance compliance or plan or reforestation plan. You need to know what kind of detail they need. Are they okay with just oak, maple, pine, hardwood, softwood? Then that might be good enough. More than likely, what you're going to need to do is have a forester or someone to go out and do a tree identification survey and tag all the trees and give you a schedule that says, you know, tree number 30 is a 12-inch maple. And so you'll be able to at least say, I can believe that. It's not a 36-inch pine, so we're just going by the tagged trees, and that's what you locate by, so that the surveyor's not on the hook for misidentifying a tree. Some other professional who that's what they specialize in, that's what they do. Arborist was the term I was looking for. An arborist will go out and do a tree identification, and they'll create a spreadsheet and a little bit of a sketch. This is what you're looking for. You can come along and do it. Now, that could even become something that you need to do with a tree that is a call for property monument. You never know. But here you have black oaks, live oaks, pin oaks. These are all in the red oak family. Water oak. A willow oak is more along the lines of a live oak. So in oaks, I'm just going to give you a real quick glimpse. You kind of have the family of live oaks that have slender, longer oak leaves that usually live in an area with a higher water table where it's flat. You usually find them in South Georgia and Florida, or in city parks in North Georgia. And you have red oaks and you have white oaks. And a lot of these are just true variations. You know, the typical red oak tree is what they call here a scarlet oak tree. Some of the old deeds call them Spanish oak trees. So we're not going to go into all this much detail. Just know that if a deed calls for a post oak tree, you need to go find a chart and find this is what the leaf looks like. Find a picture of what the bark looks like. Make sure that you identify it correctly or not at all. Drainage structures. So drainage structures are not always property boundaries or property boundary corners or elements, but they can be. For example, if a stream has been piped, there may be a pipe in there. If the stream's the property line, the pipe's part of the property line. You need to be able to correctly identify it. A lot of times if a stream or a ditch is a property line, the ditch or the storm drainage structure will be shown on the survey just so that whoever's looking at the survey knows, okay, it goes down to here. Why does it become necessary to properly identify these? A couple of reasons. One, if you're looking at a plat that says 24-inch CMP, that tells you that you're looking for a pipe made out of corrugated metal that has an inside diameter of 24 inches. If your crew or yourself finds something different, well, there's a good chance that that road's been blown out and that culvert's been replaced. They may have done some alterations on the ditch or the receiving waters or the discharging end when they replaced the culvert that could have changed the stream location. If you're finding a difference in measurements along a road, for example, don't just kindly disregard it as, well, that's a stream, that's a riparian boundary. You might have to look a little bit further. If the natural stream channel is still there and can be identified, even if the stream's 5 feet away, if it's a little small stream, the previous location is still the property line. Refer back to riparian law. Another thing is, of course, well, there's kind of a second thing. We typically will show them on a boundary survey to some extent. On a final subdivision plat or an as-built survey, we're going to be asked to show them with great detail. Now, that brings us to the third thing. Surveyors need to be able to properly identify what they're locating. That's been the theme of this lecture. So it's easy to mismeasure or misidentify a pipe, especially metal and plastic pipes. They get squished if they're not bedded and installed correctly, which they sadly rarely are. A 18-inch pipe may be 17 inches high and 19 inches wide. That doesn't mean that it's a 17 by 19. Doesn't mean it's a 19 if that's the only side that you measure. Doesn't mean that it's a 17 if you measure the other side. You need to look at it, determine that this product, which was bought at the supply place, hauled in, signed off on, laid in the ground and covered up, was an 18-inch corrugated metal pipe. There is no such thing as a 19-inch corrugated metal pipe. There is no such thing as a 16-inch corrugated metal pipe. You're measuring something wrong. Now, why does this matter? If you call it a 19-inch pipe, and that's the only mistake on your entire plat, but there's a question about a property line, you've got it dead to rights. You've got it absolutely correct. The opposing side can drill you, embarrass you, and discredit you over a 19-inch corrugated metal pipe. Has nothing to do with the problem at hand, but it can absolutely be used to discredit you and show you as being incompetent. Got to pay attention to detail and only put things out there that you can back up. This picture in the bottom left is reinforced concrete pipe, or RCP. I like this picture because you can see the female end of some pipes here. It has this ring around the inside that's recessed. That's for the male end right here to seat into. Or here's the correct size here that I've drawn a circle of in the middle. The male end fits into this socket and you're good to go. A lot of surveyors will make the mistake of measuring this as the diameter of an RCP pipe, because on the inlet end, this is the side you're seeing. The actual inside diameter, which is over here, it's further back up in the pipe, maybe a few tenths. Want to get done in a hurry, maybe a little bit of carelessness. The inside diameter of the lip will be measured instead of the inside diameter of the pipe. That's how you see things like 46-inch or 50-inch RCP. No, there is no 50-inch RCP. As the material shows, starting with 12 inches, they're in 3-inch increments up to around 30. You don't see 33 inches, then they go to 6 inches. So it's like 30, 36, 42, 48, 54, 60. Somewhere in there, the generally available ones go to 1 foot increments. So they'll go 60, 72, 84, 96, and seldom you see more than about 108s. I have saw some 144s, which are 12 foot diameter, but you don't see those too much anymore. So, keep in mind over here, this is the diameter of the pipe. If you can imagine where the metal has been cut, you might measure, just say this is a 48-inch pipe is what it looks like. You might measure 49 inches if you catch it inside the corrugations, or on the outside of the corrugations. But these corrugations, these waffles, if you will, in the pipes, you got to look at the inside diameter of that and know that they don't make 49 inches. They make 48s and then they jump to 54s. So, be careful about that. So let's summarize and close this out. Many opportunities to misidentify and mislabel features and objects that are found. Such errors can create unnecessary hardships, problems, burdens. Already mentioned this, consider a plat that shows a 19-inch CMP as part of a boundary dispute. and consider that the identification of the erroneous diameter is the only problem on the plat, this rookie mistake may be used to discredit or otherwise, an otherwise flawless plat by a prudent surveyor. Or there again, you got the 3/8 versus 1/2 inch rebar analogy that we already used. So again, just think about natural objects, artificial objects, trees, drainage structures. The legal aspect of this is accurately describe it, identify it, call it out on the plat, because whatever we do as surveyors, some other surveyors are going to come behind us and retrace us one day, and they need to be able to follow in our footsteps. And if we tell them it's a 1-inch open top pipe and it's actually a 3/4 inch open top pipe, they've got to pause. They've got to scratch their head. They've got to make a judgment call. Is this the same pipe that Mark Chastain found in 1994? Don't know. We might have to back up and see if this is a different pipe that somebody's drove since then. Might require a lot of additional work, consternation. Heaven forbid it causes a pin farm where somebody says, well, the deed calls for a 1-inch pipe. This is a 3/4 inch pipe. So let's go drive a pin in the right place. My math and my fancy device says it's 2/10 away from this open top pipe. Let's go drive a rebar at the base of it and make the whole surveying profession look like a bunch of dummies, confuse the neighbors, and make it look like we think we're smart when the whole world is just shaking their head. Don't do it. Get it right, describe it right, do good work. It's not impossible. It's not even all that hard. I would even suggest that it's harder to do bad work than it is easy to do good work. So let's focus on attention to detail, think about the legal aspects of what we're doing, and survey on.